Welcome to The Explainer. Today we're diving into an absolutely impossible archaeological mystery that pretty much completely rewrites the history of human technology. We usually think of technological progress as this straight, unbroken road leading right up to our modern digital age, right? But today we're going to look at a single artifact that proves history is definitely not that simple. It's a fascinating story full of breakthroughs, dead ends, and entirely forgotten ideas. Let's get into it.
I want you to just imagine for a second, discovering a complex machine built more than 2 millennia ago. And we aren't talking about some simple tool or a primitive weapon here. We're talking about a highly intricate device packed with gears, dials, and mechanisms that were specifically designed to calculate the movements of the heavens. Now, imagine that exact level of mind-blowing technology just completely disappearing for centuries. No copies left behind, no instruction manuals, almost no surviving explanation whatsoever.
Section 1. The Underwater Discovery. A Shipwreck's Secrets. So our story actually kicks off right in the Mediterranean. Around the 1st century BC, a ship carrying some seriously valuable cargo sank near the Greek island of Antikythera. For nearly 2,000 years, 2 whole millennia, that wreck just sat there, hidden underwater with its secrets perfectly locked away in the deep. It wasn't until the year 1900 that a group of sponge divers who were just out looking for their next catch totally unexpectedly stumbled upon the wreck. And what they brought up to the surface was, well, absolutely remarkable.
The divers pulled up what you'd probably expect: standard, albeit beautiful, ancient treasures. We're talking statues, coins, jewelry, and really intricate glass objects. But sitting right alongside all that wealth, almost like an alien object dropped from space, were these fragments of a strange, heavily corroded mechanism. At first, literally nobody understood what this object was. It just didn't look like anything familiar from antiquity. It was essentially just green, rusted pieces of bronze, fragments of gears, inscribed surfaces, and what clearly looked like carefully engineered mechanical components.
Section 2. Decoding the Mechanism. Looking inside the bronze.
Once these fragments arrived at the National Archaeological Museum in Athens, scientists were just completely baffled. And for decades they struggled. The main issue is that the mechanism had only survived in broken pieces. Centuries of saltwater corrosion had basically fused the parts together into a rock. Many components were missing entirely. Traditional archaeological examination could really only reveal so much before you risked destroying the fragile artifact itself. So advanced X-ray imaging became the absolute turning point here. These scanning techniques allowed scientists to finally peer inside the internal structures without physically breaking the mechanism apart. And that high-resolution imaging revealed hidden inscriptions and incredibly complex gear arrangements, which eventually allowed researchers to reconstruct missing components and even build fully working modern replicas.
Section 3. An Ancient Analog Computer. Turning Math into Motion.
So those high-resolution images revealed a sophisticated system of interlocking gears. But to really grasp what this means, we kind of have to reevaluate what a computer actually is. Fundamentally, computing is just about manipulating information according to a set of rules. It doesn't actually have to be electronic. A physical gear can represent a number. A rotation can represent a passage of time. A mechanical relationship can track a massive astronomical cycle. By transforming complex mathematical relationships into physical mechanical operations, this device was, essentially, turning math into motion.
And I think this brilliantly illustrates the massive leap in logic we need to make when looking at this thing. We are all so incredibly used to our modern computers, right? They're made of silicon, packed with microchips, and they run on electricity. But the Antikythera mechanism achieved a conceptually familiar goal using nothing but bronze and gears. Ancient Greek engineers were literally encoding complex astronomical mathematics directly into solid metal. And they were pulling this off with technology from more than 2,000 years ago. It's just wild.
Now, these gears were highly functional. Ancient Greek scientists had already developed these beautifully detailed models of celestial movements through studying math, geometry, and astronomy. This mechanism took all of those abstract fields and slammed them together into one physical device. Specific gear ratios were explicitly designed to represent different astronomical cycles. It had these intricate indicators specifically tracking the sun and the moon, and one absolutely amazing feature was a complex gearing system that actually mapped the relationship between lunar months and the much longer cycle associated with predicting eclipses. It was, for all intents and purposes, an ancient mechanical calculator.
But, of course, this brings up a massive, glaring mystery. If they had the brains and the tools to build something this sophisticated back then, why don't we see similar machines everywhere in the archaeological record? The precise origin and purpose of this specific device is still heavily debated.
It represents a level of mechanical sophistication that was just exceptionally unusual for the time, so it likely wasn't some everyday household object. Experts think it could have been a highly specialized scientific instrument, maybe an advanced teaching tool for astronomical concepts, or perhaps a one-off custom creation for a very wealthy, elite owner. But whatever its exact purpose was, it definitively proves that a highly advanced engineering tradition did exist.
Section 4. The fragility of knowledge, when civilizations forget.
So why did Europe not enter a full-blown mechanical computing revolution 2,000 years ago? Well, because of a massive, undeniable gap in time. Over 1,000 years. That is the staggering timeline between the creation of the Antikythera mechanism and the emergence of the very next mechanical calculators. Things like the mechanical clock didn't become a big deal until much, much later in medieval Europe. The Antikythera mechanism completely shatters our common assumption that technological history is just this straight upward line, where primitive tools appear, machines naturally get more complex, and civilizations just constantly advance.
So how exactly does a whole civilization just forget? Well, you have to remember that knowledge doesn't exist in a vacuum. Over the centuries, priceless written records were just lost to time. Great sprawling libraries were destroyed. Entire cities were completely abandoned. Political systems collapsed, and massive trade routes totally disappeared. And perhaps most importantly, specialized knowledge often depended on very, very small groups of experts. When those specific experts vanished, whether through war, famine, or societal collapse, entire manufacturing traditions just vanished right along with them.
This is honestly one of the most important lessons in all of technological history, and it's perfectly captured in this quote from our source material. Technology isn't just objects. Technology is knowledge, and knowledge can be fragile. For technological progress to survive, it requires sturdy institutions, education, careful documentation, and people actually capable of passing that deeply technical knowledge down from one generation to the very next.
It's a really sobering thought, isn't it? The most advanced technology in the entire world is utterly useless if nobody around actually remembers how to build it. Just imagine having a giant factory packed full of cutting-edge machines, but literally zero engineers who understand how they work. I mean, sure, the machines might keep running for a little while, but then a belt snaps, something breaks, and the repair knowledge is just gone. The manufacturing process is completely forgotten. Eventually, the technology simply disappears into the dirt. The Antikythera mechanism survived as a physical, tangible object for thousands of years underwater, but the actual instructions on how to make it disappeared from the face of the Earth completely.
This single artifact really changes how we think about human progress. We always like to imagine that every single generation becomes naturally more technologically advanced than the previous one, that we are constantly building the future for the very first time. But the Antikythera mechanism is this incredible reminder that the future actually has far deeper roots than we ever imagined. Sometimes the technology isn't out there waiting to be invented, it's just waiting to be rediscovered. The world completely forgot how extraordinary these ancient engineers really were, right up until the sea finally decided to give this artifact back to us.
So I want to leave you with this final provocative question to chew on. You see, archaeology isn't just about digging up cool old objects. It's about recovering lost information and recognizing that human progress is never guaranteed. If an ancient society could figure out how to build a mechanical computer, encode complex astronomical mathematics into solid metal, and then just completely forget how they did it, what modern knowledge, which relies entirely on our own fragile networks of experts and institutions, might we lose tomorrow? Think about that for a bit, and keep exploring the incredible and highly fragile history of human invention.